Hi there, Husky. So I just wanted, happy Friday, by the way. Just wanted to make that clear. We're on lesson 4, or you should be lesson 4, on your comparing and ordering rational number sequence. So I want to go ahead and briefly cover what you should have had for last period. Um, Last time we covered lesson 3, and that was classifying rational numbers. So we're going into what that means again, right, for this document. So I'm going to go ahead and share, present, so you can see what I have here, and then I'm going to make like little notations on what you should have had and explain it. Okay. So as a review for using a Venn diagram, if someone, we're looking at this diagram of Texas, Harris County, and Houston, right? A Venn diagram, whatever is inside of it, that's what it's related to. So A, if someone is from Houston here, are they actually from Texas, which is this big bubble all around it? Why or why not? The reason it'd be yes. And the reason why is because Texas is this big old state, right? Harris County is the county, and then Houston is like the city. So Houston is already part of this big category. So, yes, right? Texas would be part of it. Comma, Texas would be part of it. I'm not sure if I can type here. Let me see if I can type here. Okay. Well, basically, Texas would be a part of it. So I'm just explaining it. Okay. So you would explain why. B, if someone is from Harris County, are they also from Houston? Absolutely, because it's still part of that county, right? Like, for example, you have Los Angeles County. Gardena is the city. So you would have Gardena still part of that Los Angeles. So that's still a yes. If someone is from Austin, Texas, then would the Venn diagram, which of the Venn diagram do they belong? Well, if you look up Austin, Texas on a map, you can see that it is part of Texas still, but it's not necessarily part of Harris County. So they would probably belong just in Texas. Okay. All right. So again, we also reviewed rational numbers, integers, whole numbers. We know that whole numbers are positive whole numbers. Integers can be positive and negative, and rational numbers are basically, decimals, fractions, and repeating decimals, right? Fractions, terminating decimals, repeating decimals. So we'll go ahead and move on to the next section. Clear this. Make sure you watch the whole video, okay? Because we're still covering a lot of it, of what you might see. So here, use my pen. Type in X in every box, that category that applies. So 7.3 would not be a whole number, but it is a rational number. Okay. 0.41 is going to be a rational number. Remember, integer is straight up negative or positive, right? 6 is a whole number, integer, and a rational number. Okay. 3, well, let's double check really quick, actually. So if we go back, oops, you can see, okay, so it covers all of that. I just wanted to be sure. Okay. So actually, I was wrong on here. So it would not be a rational number. It'd just be whole and integer. 3.5 would be, actually, let's go back really quick. I'm sorry, you guys. Okay, so I'm going to go back on here, and it says rational. So it would be, okay, so this is rational numbers. It would be a rational number because it's part of that, all of that category. So we're going to go back. So it would be a rational number 2. 3.5 would be a rational number, but it would not be an integer. Okay. -3 would be an integer and a whole number. Okay. 3.5 would be mostly rational because it's a mixed number. Rational numbers could be integers and whole numbers too. Okay, so we'll leave it at that. Now come up with your own Venn diagram. Well, I'm going to go ahead and let's do California, right? CA for California. I'm going to do LA County. And then here we have Gardena, right? There we go. Now we drag the numbers to the correct category. Whole number 100, 0, 57. Integers would be, let's say, so we got that out of the way, 57, 0. Our integers would be -29, -1 4/5, -6. Okay. Now in our rational numbers, which is mixed, it'd be 2/3, right? -1 4/5. So I'm just going to put that as a 1. So -1 4/5. 6.2. Okay. And then that would be it. Okay. So covered that. Let's go back. If you need to pause the video to make sure that you have everything, you can do that. That's fine. I'm going to go ahead and erase everything. Clear screen. Okay, let's go to the next section back. Okay, so we're in lesson 4, and now we're comparing and ordering rational numbers. So our objective is I can compare and order rational numbers by rewriting them in decimal form. Okay, let me go ahead and move. Yeah, rewriting fractions and decimals with accuracy. So when we're converting decimals to fractions, this is when things might get a little bit confusing. So it's important that we understand the place value. We use place value to determine how to convert decimals. So let's look at 0.47 for an example, okay? This would be, the 7 would be in the hundredths place, okay? Hundredths place. So it'd be 47 out of 100. That's the hundredths place. Now, if we add another number to the right, let's say in 0.125, that would be the thousandths place. So that'd be 125 over 1,000. Okay. So just to make that clear, let's say we have a 0. Let's say 3, right? That would be 30 thousandths because that 0 is still right there. Now let's look at this example here. We have 8.03, and that number would still be in the hundredths place. So that's what it would be. Okay, so let's go ahead and look how we can convert fractions to decimals, okay? So one way of doing it is use equivalent fractions. We rewrite the new fraction using a denominator of 10, 100, or 1,000, okay? So in 17 over 20, I need to find the same denominator here. Okay, I know that I can use hundredths to find out my answer. So to get to 100, I know that if I multiply times 5 on the denominator, 20 times 5 equals 100. That's what I would get. But because I got times 5 on the bottom, I have to put it up in the top, multiply 17 times 5, and I get 85. Now, 85 over 100 translates to 0.85. Okay, let's look at example 5. We got 3 out of 500, right? So with 500, I can't just leave 500 and turn it into 100, okay? It's not going to work out for me. So the next biggest number up on the decimal scale I can get is the thousandths place. So I'm going to times whatever it is to get to 1,000 on the denominator, right? I have 500. Let's say I don't know this. Blank equals 1,000. So I know, right, that if I multiply by 2 on the bottom, 500 times 500 would equal, 500 times 2 would equal 1,000. And if I times 2 on the bottom, because whatever I do on my denominator, I need to do on my numerator. 3 times 2 is 6. So that's going to be 6. 6 over 1,000. So what's that? That's going to look like 0.006, right? Because this position is the tenths. This position is the hundredths. And then this position is the thousandths place. Now let's look at this type of number. Okay, so we have 36 and we have 40. Okay, so I could go to hundredths if I really wanted to. But I know that if I wanted to keep it simple, because it's still in the tenths, right, I can do it to the tenths place. So I'm going to decide to divide by 4, right? I can see here easily that if I divide 40 divided by 4, I can get 10. So whatever I do on the bottom, I'm going to do on the top. Okay, 36 divided by 4 is 9, so that's 9 tenths. It would equal to 0.9. But we know that it's technically can go to 0.90. So if you did, like, for example, if you didn't know what's on the top, right, and you just have this fraction, you have 40, and then you have 100, you could, of course, times 40 to whatever that denominator or that other number you need to multiply to get to that. You could technically do that to get it to 0.90. But again, that's just more work, right? In math, we want to keep it simple. All right. The second method to convert fractions to decimals is this. Let's say we have 5 over 8. Okay, so 5 over 8, we have to do long division. We put the 8 on the outside, and we do 5.000, right? So we divide as much as we can get and put those zeros down until we get the fraction 0.625. Okay, now this might be tricky. You might think, oh, but Miss Monterre, the A is supposed to be in the box, not the 5 on the outside. Well, the thing is, remember I talked about A over B? That if you have a fraction on top that's smaller than the fraction on the bottom, that means that you have to add extra zeros, because on the conversion scale, right, we can go to hundredths or thousandths. You're going to have to add the extra zeros. And when you get to long division, it would equal to 0.625. And let's look at example 8. This might be a simpler way to think about it. So we have 1 divided by 6. Okay, that's great. Well, what do we do? Well, if I divide 1 and put it in my box and add the 6 on the outside, then, of course, we do 6 times 0 to 1. Can't get anything, it just equals 0. 1 minus 0 is 1. We bring down the 10, right? And then now we have to add another 0. So it's 6 times what equals 10? That's 1. Minus 6 equals 4. Bring down another 0. So we add an extra 6, right? 6 times 6 is 36. 40 minus 36 equals 4 again. We add another 0. 40 minus 36 is 4. Now, it's just going to keep on repeating and repeating. So it's going to be 0.166666 forever to infinity and beyond. So if we have that situation and it keeps on, there's no end to it, no zero soon after, let's say, the third placement, then we put a line on top of it to indicate that it's a repeating decimal, okay? All right, I know this is a lot to catch on, but I just want you to review. Okay, so let's say you're done with that, and we go back. And now for your worksheet, you have to use your understanding of division to complete the table, okay? Type your answers in the purple boxes. So you have to show me, let's say 3 out of 5, we can do this together, how that's going to look like for you, right? So think about A over B. All right. So I know it's going to be 3 divided by 5. And because this looks like I have to divide it with the decimal, it looks like it's going to be 3 is going to be in the middle and the 5 is going to be outside, and then I'm going to have to add more decimal places, right? So just as a hindsight on what you need to do. Here with 5 over 4, we know it's a over b, right? Whatever we have, a over b. So in this case, it'll be a mixed number, not mixed, but improper fraction, 5 over 4. So then that would make it 4 here and the 5 on the outside, okay? And then we're still going through it as we go. So use those 2 examples to help you. Now, in using the number line, you're going to use, we're going to graph the decimals, the number line below from greatest to least, okay? So you're going to put in what's going to be on the negative side, what you think, to the other side. Now let's also try this. You can drag these numbers, drag them to the appropriate points on the number line. So you graph the following decimals by on the number line by dragging the points. So here's your points, and you put it accordingly, okay? Here's another way we can go. So we go back, and then I'm going to go here. Okay, let me clear here. All right, so now you got to write each fraction as a decimal, right? This is what we're talking about. So this is going to be a little bit difficult because you might not have had a lot of practice with this, but that's okay, right? Math is all about when we make mistakes, we figure it out and we learn from them, all right? That's in life, that's in math, that's in reading, that's in life, okay? So here's a little bit of a trick. If you have a over b, right, the a goes in the box, that means negative 2 over 5. You're going to have to use 2.0, right? And keep on going on until you get that decimal point. If it's repeating, you stop. If after 3 places, then you can actually, and you get a 0, then you can use that place value, right? So you're putting it in a decimal. So with negative, it would still be a negative here, right? A negative decimal. Now, again, I'll give you that little bit of help. So that's 8 over 3, right? So 3 is in the box. 3 over 8 translate to this. With the mixed number, you're going to have to multiply, then add, right? To find out the fractions, so then you can figure out the decimal. 5 over 4, that again is 5 in the box and 4 on the outside, okay? To convert the decimal as a fraction, again, 0.55, I have to times, since this is in the hundredths place, right? Blank equals to 100. Okay, so that means that 0.55 is going to be 55 over 100, right? Or it could be 1,000ths even if it's 550, right? But again, to the hundredths place. When we go to putting these in order from least to greatest, that's simple. And then number 11 is out of 45 times a bat, Carlos Correa got 18 hits, right? So that means 45 out of 18. Or actually, I'm sorry, 18 over 45, right? His hits are what we have here, and then 45 on the bottom. So how would you change that into a fraction? That's your fraction. And how would you convert that to your decimal? Okay. All right, class. So work on this for Friday in class. And then after you are done, you're all finished. All right. Make sure you turn this in on Friday night. Even if you feel like you didn't get it right, just work on it so then we can go over in the next video. Okay. All right. Great job, everybody. Have a lovely day.